and today we are going to define our next term. So far we have defined the following. We have defined distance, we've also defined displacement, we've also defined what speed is, we've also defined velocity, and we have acceleration as the last term in this topic. So we are going to talk about acceleration today. Acceleration. And before we go to acceleration, I would like to review what we covered previously, that is in velocity. The previous lesson we were looking at velocity. Just to do a reminder, we said velocity is the change in displacement, per unit time, change in displacement per unit time, whereby we say therefore if we use v to represent velocity, therefore velocity v is equal to displacement per unit time. S, which stands for displacement, then t for time. Velocity is the change in displacement per unit time. And then we said velocity is a vector quantity. Velocity is a vector quantity. And we say that whenever we are calculating velocity, we consider both the size and also the direction. So it is a vector quantity. Then again we said if there is equal change in displacement, or if there is same or equal change in displacement, that is per equal time interval, change in displacement, if there is equal change in displacement per equal time interval, no matter how the intervals may be, we say therefore that the body is moving at a constant or uniform velocity. The body is moving at a constant or uniform velocity. That is, if there is equal change in displacement per equal time interval, no matter how small the time interval may be, then the body is seen to be moving at a constant or uniform velocity. If that is not the case, then we say that the body is moving at non-uniform velocity. If the velocity is not uniform, if it's not this case, then we say that it is moving with a non-uniform velocity. Then we also need to know that if we have velocity at a particular time, velocity at a particular time is referred to as instantaneous velocity. Is referred to as instant, from the word instantaneous velocity. That is velocity at a particular time. We refer to it as instantaneous velocity. Velocity at a certain point at a particular time is what we are referring to as instantaneous velocity. So today we are going to move on to our last term, that is acceleration. And by the end of this lesson, you'll be in a position to define acceleration. Define acceleration. Again, you'll be also in a position to get to calculate any question involving the numerical, that is the numerical calculations. That is for acceleration. Those are the things that we should be able to do by the end of the lesson. So I want us to start by the definition of acceleration. When we talk of acceleration, it simply refers to the change in velocity per unit time. It refers to change in velocity per unit time. Change in velocity per unit time. Or we can say it is the rate of change in velocity. Simply the rate of change in velocity. That is simply what we refer to as acceleration, the change in velocity per unit time or rate of change in velocity. So therefore, we say that acceleration is equal to change in velocity, change in the velocity per unit time, so divided by the time taken. Change in velocity per unit time. That's how we define acceleration, the change in velocity per unit time. And therefore, we also need to know that acceleration is denoted by a small letter a. Acceleration, we denote acceleration is denoted by a small letter a. This is the symbol for acceleration. It is not the SI unit. We can even write it here. So we have A for acceleration, a small letter a. And therefore, we can go ahead and therefore say, when we want to get the change in velocity, will simply be given by the final velocity minus the initial velocity. We'll have the final velocity. For us to have the change, we have the final and the initial. So the final velocity minus the initial velocity. That's what will give us the change in velocity. And therefore, we can go ahead and say that acceleration will therefore be equal to change in velocity, which is final velocity minus the initial velocity. Final velocity, we subtract the initial velocity, we divide by the time taken. This one will give us the acceleration. So acceleration is the rate of change of velocity, or simply the final velocity minus the initial velocity divided by the time taken. And therefore, we also need to know the symbol that we use to denote the final velocity. The final velocity, we denote it using a capital letter V. We use V. Then for the initial velocity, we use a small letter U. So ensure that it has the tail. And as we know, for time, the time, we use a small letter T for time. And therefore, from this formula, we are going to have that acceleration, therefore, acceleration A therefore will be equal to final velocity V minus the initial velocity divided by the time taken. So this is our acceleration, the change in velocity per unit time, or the rate of change in velocity. So we have the final velocity minus the initial velocity divided by the time taken. That's what we have for acceleration.